We present a unified approach to robotic tool tracking under a partially visible kinematic chain. In scenarios where the camera is positioned to better perceive the robotic tool and environment or objects of interest, a portion of the kinematic chain is never seen in the camera view. An example of this is shown here. Only the gripper of the surgical robotic tool is visible in the camera frame, and there are an additional 4 degrees of freedom out of the frame. To fully describe the robotic tool in the camera frame, standard forward kinematics is combined with a base-to-camera transform, which is typically calibrated for. In this work, we consider errors on the base-to-camera transform, as calibration of this transform has higher sensitivity in scenarios where the kinematic chain is partially visible due to the limited range of motion the end effector can take during the calibration. We also consider errors in joint angles, which can be caused from a variety of complex transmission effects and biases from encoder readings. Direct estimation of all these unknowns, however, is infeasible because of a many-to-one mapping between the unknown parameters and images of the visible robotic tool. To overcome this challenge, we propose a parameter reduction technique we call lumped error. The lumped error transform can be estimated directly and lumps together errors in the base-to-camera transform and the non-visible joint angles. To track the lumped error, we proposed a particle filter which can utilize a variety of visual features such as markers, edges, and learn key points from deep neural networks. In this experiment, the lumped error parameter reduction is utilized to track one of Baxter's robotics tools and uses deep neural networks to extract key points from the robot manipulator. The lumped error parameter reduction is also extended to eye-enhanced scenarios, which is when the camera is mounted on a robotic arm as seen in this video. The results show that the proposed lumped error parameter reduction is an effective technique for robot tool tracking under partial visibility of the kinematic chain. Thank you for listening.